welcome to another episode of the DIDAS Health webinar. We have a special guest today. I'll introduce him shortly, but before we move into this presentation, I would like to say a few words about DIDAS, since you have a number of participants who probably don't know who we are. Program for today, as I said, I will spend a few minutes on introduction. Then we will hear Jannis Schönleber from 44 AI with a presentation and a live demonstration of his solution. And then we have time for discussion. And if you want to proceed with your previous discussion, then we should have time at the end. Who are we? Who is DIDAS, or DIDAS in English? We are an association which is focusing on self-sovereign identity principles. Currently, the main activity is in our National Digital Identity, or EID as it's being called here. So these are the main activities, very similar to the EU activities. But what most people don't realize, with this EID comes a trust infrastructure which can be used for many other things. And this brings me to the next slide. I've all taken that from the website. So if you want to deep dive a little bit deeper, then you can check out the website. So we are organized in working streams. We have horizontals, such as a technology group, an adoption group, a governance group, and we have verticals in the various subject areas. So health, as we are, we have public sector, transportation, and a number of others. So check it out in detail if you are interested in that. Then, as I mentioned, we have working groups. So every stream has a working group lead. We are currently in the health working group, obviously, but there are other working groups. And here you see the faces behind the working groups. And as we are talking about DIDAS, we have regular video calls, but once in a quarter, we have a physical meeting. So the next one is scheduled for 22nd of November, so in 2 weeks' time, where we typically go to one of our corporate members, visit them, have presentations, conversations there. It's open for guests. You don't have to be a DIDAS member to attend. So for those who are in Switzerland, you're welcome to join us. It's on Eventbrite. So if you look for DIDAS year-end event, you should be able to find it. And another thing which I would like to point out, we started out with a key messages for DIDAS Health, and in the course of the conversation, it turned out it needs to be scoped a little bit wider, and it's now being developed as a Swiss Digital Health Manifesto. And we are liaising with other associations in a similar field. Just to let you know, there's another manifesto being prepared, which has really the DIDAS perspective with the self-sovereign identity principles. After this introduction, I'm already with our guest speaker. So it's Jannis Schönleber. He is an ETH spin-off. Basically, he's converting text, be it written or spoken, to structured clinical data. The company is 44 AI. He's the CEO, if I'm right, he's also the co-founder. And he is really a hardcore developer, as I found out. So he's doing all this stuff by himself. So basically, he's the senior developer, full stack and mobile. Jannis, thank you very much for taking the time and for presenting your solution. So the floor is all yours.
So hello, everyone. Thank you for the introduction, Peter. Very happy to be here today and discuss this with people that are interested in this space. So as Peter introduced, I founded a company this year which focuses on the medical data structuring, but also very important, we focus heavily on the privacy of the data, as you will see later. So let me just quickly jump in. I have around 5 slides, and then we will go into the demo and show where we are at the moment. So the problem we have in healthcare space, most of you are probably aware of it, but let me quickly draw it out. So we have all of this different modality of data that are created all through the day, all through the year. And as you know, there is more and more data created, and it's somewhere stored. Hopefully it's stored somewhere, or it's not even stored, and most of it gets lost somewhere in this big sauce. So we have this problem of multimodality. We have the audio, we have the texts and PDFs. And then we also have this ever-increasing amount of unstructured data is created, but somehow the system is not capable of managing it properly, in our opinion. Another issue we see is that this administrative task workload for the healthcare professional is increasing year by year. I looked at the GFSBN and FMH survey that they did last year, and it's more than 40% of the task time of a healthcare professional to spend on these works, and this is growing year by year. So we say this is not sustainable. We are probably not the only one. So what is our solution that we are proposing? And we are also certainly not the first one to propose that. We have the structuring engine that we developed internally. So what does this do? We take all of these different data modalities and we map it to a structure. I know some of you are very interested in OpenEHR. So we at the moment we support FHIR, but for us it wouldn't be a big issue to also include OpenEHR to kind of get this question already answered. And then what we want to do is we go down to the structure and then enable all these downstream tasks that most of you probably already can think of, can the classical ChatGPT case, generate a report, improve the data reporting, make it as a meaningful patient cockpit, and then the classical case would be based on this guideline suggestion. But we strongly believe that we have to go down to the structured data to get out of this evaluation hell that we have otherwise, that we just have this big black box that's, let's say, the big companies are building, where you have this Eierling, the Wollmilch now, where you have no chance of tracing what happened in the decision-making process. So to get the quick rundown, we structured this to enable accurate and reproducible AI-based downstream tasks. Our goal, our mission is to reduce this administrative workloads by up to 80%. And this would be around 2 hours per healthcare professional per day. At the end. And then what's also very important, we have full privacy. Everything you will see later on, all the AI models we use, all the AI steps we use are in-house. Of course, they're based on open source. We cannot train a full foundation model by ourselves, but we want to control that such that we don't have any third-party services in the pipeline. So maybe the question you have is why? I am not a doctor. I was invited here at the Inselspital to visit for a day. But fundamentally for me, the background I have is actually electrical engineering at ETH. I worked at big tech on their AI stack on a very low level. I went back to ETH to do a PhD in hardware design for AI. And I was basically focusing on what is coming. I saw the wave that was coming firsthand. But I also had in parallel a bit of a health issue where I was really frustrated with the system because I lived in Zurich. My home doctor was in Basel, where I came from. There was no information flow. I went to multiple doctors. Everyone was telling me the same. But in the end, I solved the problem by just calling my mom. And she told me, oh, it's probably this because I have this too. And for me, this was like this eureka moment of the data flow is completely not there in the system. And then I looked into it, and 5 months after this, I was basically ready to quit my PhD, and I did that in February, and now I'm all in, and here we are. And it's, of course, not only me, it's we are a team. Not all of them are working full-time. We also have a medical advisory board that advises us, gives us the medical insight. And that's kind of the state where we are now. This was a quick rundown of our company, but I would say let's jump into the demo and then you understand a bit more what we are doing. So as I said, so what we do is we try to get all these different modalities down to a structured, exchangeable format. And so just to give you a very bird's eye view of what we do in the back end. So what we do fundamentally is we take the audio, we of course transcribe it, go to text, we take the PDFs, we do OCR, go to text, and then behind that, we have our text structuring engine that structured is down to condition, medications, allergy, so on and so forth. And what we do is also we try where we can to give an ICD code where we are certain enough. And we also supplement it for the people who code with SNOMED qualifiers. For example, here you have keine Hinweise auf eine Herzkrankheit, and we supplement it with definitely not present. And for example, for the medication, we also get out the dosage that was represented in the text, and so on and so forth. So this is kind of the heart of it, how it works. And let me quickly jump into audio example. that you understand when we come from this audio modality. So I have a quick example to put into the machine here. So with our medical advisory board, we made some demo samples that we can show. So no privacy concerns here. I hope you can hear the sound now.
Für Telehealth-Medizin am Apparat. Frau Schönleber, habe ich gesehen, rufen Sie an. Können Sie mir kurz erzählen, wieso Sie heute bei mir anrufen?
Genau, das ist eben, ich rufe an, weil ich nicht mehr zum Arzt kann.
So as you can see, I hope you could hear it. So this was a Swiss-German doctor, Swiss-German patient conversation. And what we do on the right side here, you see the WhatsApp chat, as we call it. So we not only translate it, we also do the diarization, so we can decide what did the doctor say, what did the patient say. And one thing we fundamentally focus on is that we always have the back referencing and the white boxing. So what do we mean by that? For example, we can go in here and we can click on it in this case, and we can go back.
Wenn ihr Sport macht, habt ihr dort irgendwie bemerkt, dass irgendwie sich etwas noch verändert hat, dass es Schmerzen macht oder irgendetwas schwieriger ist?
Was wir vor ganz kurzem auf.
So the goal is to always get back to the original data and make this then later on, if we go down the downstream task, always available to the healthcare professional or to a patient if it is in a patient cockpit. This is our fundamental mantra, how we attack things. And then what we do here is let's say classical summary. We have here developed multiple templates. One of it is for internal medicine, and we sort it by organ system, and we get out what the diagnosis was, what the symptoms were, the next step, medication, and the previous let's say health issues that were present for this patient. What we're now building, or what we already had, but now building in a bit of a nicer UI, is that you can do like the classical ChatGPT from this back to a report, which would be like the full cycle for a doctor in this case. So this was the audio case. Then we had a text case. And then if we bring it all together, so if we come together, this would now be, for those of you who are in the scene, this is international patient summary style. But for us, it's mainly, we have a structured backend here, and then I call it UI juggling on top. It's kind of the user decides, or the final this provider decides how to show it. Fundamentally, before we go in here, I want to tell you that our goal is to not be the next EHR or the next PIS system. We are fundamentally want to focus on the AI, and everything you see here in this demo is built from a customer perspective. It's all API based. Everything we exchange here is either FHIR or just a plain document, nothing else, or the audio in the audio case. So what we did here is, there's also synthetic data here for this example. We uploaded PDFs, just PDFs. This is kind of the EPD case. And what we do then is we sort them by event. So we had multiple reports for each event. We give a quick summary for each event. And then we also structure the data for all of this event that came in. And what is very important for us here again is we get back to the document where we have this information from. So for each of the points we read out, we get you back to the document. And then if we, for example, go to, I'm not sure if I have an example here, we then sort it here, of course, by medication, allergies, and the vitals. And if you look here at this medication, maybe we find it. We also, for the medication we can code, we give the code if we are certain enough. In the backend, for all of these decisions, we always calculate the probability. We do that by, I can expand of that if you're interested. We do that by guided generation and multi-step generation, such that we can control our solution space, our token space. And by that, we can, for each of this decision, we can, first of all, control what we want to have in the solution space. And in the second step, we can also give you an exact probability of how confident we are. Because as you know, it's very tough to, it's impossible to be 100% on this, because medicine is not black and white. And our approach is to to release these packages where we are confident and give this information down to the user. The goal is, of course, to get this, let's say, unconfidence away over time. But we always want to communicate to the user, hey, here we have this confidential, we are this confident, and here we are not confident, for example. Yeah. So this was, I think, a very quick rundown of the demo. And I would now be ready to have some conversation about this demo, questions before we move on. I think that would make sense.
Fantastic, Jannis. Thank you very much. I really want to point out I had for quite a while the idea of my dream system, how it should look like, and now Jannis has brought it along. So that's pretty much what I imagined we should have. So that's really fantastic. But you made a very, very important point. You're mentioning by yourself that the algorithm, it's all about probabilities, and you need to somehow proofread it. So one point which I really would like to make, I'm pretty sure the AI will be the buzzword of this year, but what most people don't realize, for quite a while, for several years, I would assume, we will still need the human in the loop. And that's why my first question comes in. If you would give the generated report to actually the doctor who created it, is there a possibility that he can sort of correct it or override it?
So the reporting interface we are just now building, because there we fundamentally believe so that we will get to a point where we can 90% can be done of, as let's say, the apes work that has to be done. Like a lot of things would be Control F of all the previous reports that have been generated. And what we then want to do is to always have this reference also in the report, kind of, from Perplexity or now ChatGPT search, how they do it, where you would see this part of the report, the original information is in this report, and then you can just jump back. And then because we built this structured engine, what we want to do then is we can go back to the fundamental structure of the report we generated and the input structure we have and compare it. So for example, let's say worst case, we generate a negation. Then we would see that in the structured data and could mark it in the red. So to help the healthcare professional that he sees where we are not certain. The goal is, of course, to get this away, but let's be frank, nobody can yet guarantee it. And that's our approach to it, to be very cautious about that going down the road.
But there will be a way to manually correct it if you identify.
Of course, yeah.
Because I think that's the important thing. So once the doctor has validated it, then it's not just an algorithm generated text. It's a doctor validated document, which all the credibility in there.
Yeah. So I absolutely agree with you. There will be a human in the loop, especially if it comes to experts. So this is also one of our slogans, let the expert be experts. So the goal is to really tackle these mundane tasks, get these 80% of the really, let's say, stupid work out of the way and let them do the things. I mean, if an expert cannot decide on a thing, then why should we expect a machine to be able to make the decision? For example, if there is like one case I'm discussing with a hospital is to read out a period score of a breast scan. And then, if it's not written in the reports correctly, then no machine will be able to read out if it's left or right breast, if it's not written in the report. So, I mean, this is somehow the level I have to discuss with certain customers. You cannot expect to get out if it's left or right, if it's nowhere written. In a sense, also if there is like no indication of it, if there's just a score, for example, but it's not nowhere written if it was the left or the right breast in this case.
Yeah, you're making a good point. So if you are forcing an algorithm to make a statement, then typically the algorithm hallucinates, so he makes something up. And honestly, I wouldn't like to have a surgery based on a hallucination of an algorithm. The second point, which I would like to make, so what's really important, most people are not aware of that, and you pointed it out, but I really would like to re-emphasize it. You are really separating the data from the representation. So you have structured data in the background, but you still have the report as the doctor is used to it in the front end. And I'm very glad we have Amanda here in the call, because she, in a recent presentation, pointed out the exactly same thing. And well, I'm coming from the data side, and that's what my professor kept preaching since the 80s. So, but that occurred to me when a engineer is saying that, then the doctors typically say, well, this engineer shouldn't tell me how I should do my job. But as Amanda, as a medical doctor, presented it, it's a totally different message, because she's part of this community, and with it's really important to point out that there's a structured data behind it, and I think we need to do more education on that level. So with these things, these were the two things which I really would like to point out. But with that, I would like to open the audience.
I put it in the chat when the chat response showed that it was not sure for me that it will be seen. We tried similar things some years ago, and we at the end the problem was that the free interpretation what was written in the texts was a total failure, and then we switched to more going in a direction of named entity recognition. And the question is, do you predefine what you are looking for, or is it just an open analysis of the text, an open interpretation?
Yeah, that is a really good question. So what I try to maybe explain a bit too fast is that if you look at what the big players are doing, the the big companies, they are trying to build what I say is an eierlegende Wollmilchsau. So what they do is they hope with more training data that they get to this holy grail of, I don't know, 95%. If you look at MedLLM from Google, they're investing billions into that. But our approach is completely different. So instead of having this one big thing that can decide everything, what we do in the backend is every little subtask, as you said, is divided into a task that is, I always say, is as simple that you can explain it to a high school student and he can solve it with a high enough degree. This is for us very important that we can understand at which part we went away if there is like a misguided decision. So what that does mean? Not for everything you need LLM, as you said. So we also start with a named entity recognition in the backend. And then from this on, we just do a broad classification into, is it a condition, is it a medication, and so forth. And then we do, based on this classification, we do a more thorough search on this. Then we go into an LLM to tackle all these edge cases that can happen in free text. But also there we use guided generation, such that we have a very clear defined solution space. And to allude to the question that Peter asked, we also allow it to select, hey, all of the propositions you gave us, for example, to map this down, don't map. So if we see the uncertainty there, we already know, ooh, there's probably something we need to further look down in the road, or we make clear, hey, there is something that we cannot decide yet on. That's kind of how we approach this problem.
A couple of questions. Maybe just first, very broadly, you showed the example of Swiss German. Can we assume you can deal with any language?
Yeah, so Swiss German, I show Swiss German. We can, of course, do, but from the other case, we kind of do High German, French, Italian, English, and such as that. But you have to, I'm not in the sales crowd here, so I can tell you very open that translation is solved from a technical standpoint. The only thing we're really focusing on is Swiss German. There we're gathering data, but also here, just from the technical side, we know how to train this model. So it's essentially just gathering enough high quality data and then invest the time, which is not a lot today because there are good frameworks. We know how to do it, and then increment this model. I know this is not a good sales pitch, but under engineers, I can tell you that. Very
plausible answer. I would like to follow up on the privacy aspect. You said you have dealt with privacy in the sense I reckon that you do everything in-house, but there is more to privacy.
Exactly.
Than just doing all the processing yourself. So I was wondering whether you had tackled aspects like the identification of records possibly as well.
So we are actively working on that, but our goal at the moment is that we, for the big customers that we work on, that we do not store any data on our side. So the goal is they give it to us, we process it and give it back to them in the structured format that they can use in their framework. This is the goal. We don't want to build a new EHR system and so on. So what we do is we are fundamentally completely cloud agnostic. So all our infrastructure, we can move it around where we want. We can fundamentally also run it on premise. It's not our goal, but we are in a very slow moving, adapting market, let's say, in the healthcare space. But to tackle your point, we have one team member that we will work on this de-identification process, because if we want to use it for training, we have to de-identify before we use it for training. So this is at the moment we don't store it, but the goal is, if the user gives us consent, that we anonymize it and use this anonymized data for further training.
You were referring to confidence levels that you can achieve, and you're kind of transparent about those confidence levels. You were not quoting the confidence levels that you achieve. So I would be interested to understand how reliable is your output.
So as I saw in the previous, so we have the medications here, the allergies and the vitals. There we are very confident. And then when it comes down to diagnostic, the extraction, we are also very confident. Mapping the diagnosis, as you know, the general issue is, at the moment, the market asks for ICD codes, for example. ICD codes come from I always say the problem is there, it comes from the paying side. So there's a lot of interesting information in it, which is related to payment. But what we are working on for internal representation is more towards common data element structure, because this is more mapped to what the actual clinical information is. So the big issue we have is, if we would go down completely to ICD, what we do now in the last step, but just the mapping, is we lose a lot of medical information and enhance it with, let's say, payment information that can be interesting on the payment side. But to describe a patient, we often you lose representation. It's kind of what we see. So what we do there is we actively working together with our medical advisory board and people here, for example, Inselspital, to get this medical representation in a state, or internal representation in a state where we can confidently say, hey, this represents what the actual clinical person looks like. And then in the end, if the customer wants ICD-10, we map it down to ICD-10 where we can. And otherwise we just say, hey, this is a diagnosis, but there are like 3 codes that would map to it. And we cannot tell you which one, because we cannot say if it was Wochenbett or not, or like that.
You were not quoting specific confidence levels. So I assume you deliberately refrain from doing so. But I would be interested, and I don't want to kind of urge you to disclose that if you are not comfortable, but I would be interesting to understand, let's say, an area under the curve. How specific is your output? How sensitive is your output in terms of assessing the practicality of this implemented in real world settings?
Yeah, so if you want exact numbers, so the problem is, what is comparable data here? So what we did, we had a master thesis that worked on it for the ETH Center that I supervised, and there we used ShareClef, which in my opinion is not a very representative data set, but it's the one that is openly available. And there we have F1 scores of over 90%. But in my opinion, I think around 96 if it goes down to extraction. But this is, in my opinion, a way too high number what we achieve, what we see in real world data, because this data has been seen a long time. It's very specific to a target area, but this is the only public data set. On our private data set, we are at the moment, I would say, for medication, allergies and vitals, I don't have the exact numbers, we are at around 80% F1 score. But the goal is to get up to 95. I think then it's where we can, let's say 90, to put it correctly, 95%, where we are very confident, and the rest we can confidently say that we are not confident. Do you understand what I mean?
Yeah. So basically, you still rely on someone more efficiently than without it, but someone reviewing the data and therefore finishing the labeling.
Yeah, so the goal is to make this, let's say, from the UI perspective, from the healthcare, to make this very efficient is to have it then finally in the reports. Let's say we show this text passage in yellow because we only have 70% confidence, and this text passage in red. So that is where we see like the less burden for the doctor for the labeling and to make it most transparent, because the most dangerous thing would be to predict something wrong, and that's what we want to. So we are just very honest about it. I know there are people that claim higher numbers, but we know that's fundamentally.
I think it's a good consistent strategy. I don't want to monopolize the discussion. There are other questions. So
Manuel was waiting for to say something. Manuel, go ahead.
Thanks for the nice demonstration. I wanted to ask, how is your solution integrated into the existing systems, and how ready do you think are practitioners to use your tool, and also to what extent does it solve the exchange of data between different institutions? Does that support that as well, or would it require basically to have the different hospitals and so on to all have your solution basically?
Yes, so I will first talk status and then bits of where we're working towards. So status is we are integrated in some, let's say, not the biggest PIS systems. They, for example, use our audio API and the report generation API and the structuring API. We are talking with a lot of vendors. We are currently, let's say, not first stage, so third or fourth stage about integration. Our goal is to always be as integrated as possible. So we exchange everything in Fire. The ones who can already discuss in Fire, they can integrate the thing, in my opinion, very simply. It's just a matter of how much bandwidth they have on their side. Then we are talking also with, let's say, close provided to EPD. That is, in my opinion, let's say, think big in the future is, in my opinion, where we would have way more impact to do this structure directly on the EPD. What we do in the backend is we already extract all the EPD metadata and EPD Fire value set. And what we have already, what you've seen here, the API is fundamentally like this. You send us the PDF and the current Fire file of the patient, and we give you back the enhanced Fire file. This is the whole API we have. And this would already be API compatible with the current EPD structure. But there, it just takes some time. But we are in the talks. So this would be the ideal solution. What we're also attacking on the other side is to go directly into the hospital systems and integrate there. So, for example, some big players that already have this Fire APIs available where we could also directly integrate. But as you know, probably when you're in this space, it's most often not the technical integration that is the issue, it's the people and the politics. So that is what we are doing the most of the time now.
Following up on that question, we all know how long it can take to integrate these. Well, we have seen it with the EPD actually, how long deep integration took. Actually, it's still in progress. Are you thinking about a standalone solution? So, for example, a portal where the doctor can enter into the portal, make the necessary corrections, and in the worst case, mailing a PDF file to the HIN address of the doctor, and then the MPA has to assign it manually to the patient. So that could be a quick solution. Are you thinking about such an approach?
Yeah, I can quickly share. So what we do is, because we saw that let's say the integration way takes a long time. So what we did in parallel is we developed Heidi. So you can download in the app stores for free at the moment. So there's no payment installed yet. And basically what it does is exactly what he said. So fundamentally, you can take your hospital consultation or your doctor consultation, record it just in the app, Swiss German, what you want, select your template. And then in the end, at the moment, just send it per HIN mail. I know it's not full integration, but this is kind of a first step towards this integration process. And that's how we attack around this. And we are now integrating more and more functionality, also this IPS that you can just scan your documents into Heidi, so to speak, that we can work around this. This is exactly let's say the two-pronged strategy that we drive of putting pressure on the institution to show them what is there, and on the other side, but talk with them, because we still think it makes sense to work towards a full integration in the end.
Yeah, with that you can add value immediately for the doctors, and they don't
Exactly.
have to wait for their PIS providers to integrate that. Fun fact: yesterday evening was an event of the PIS providers. It's VFSM. It's called Innovation Event. So there is some movement to be recognized there. So we have Stefan Imhoff here, for example. He was also Jean-Pierre as well. So. That's actually a good coincidence that this path is available as well.
I can also tell you that from our side, we feel this movement. I am very much going around in the PIS world now.
Yeah, so right now, to my knowledge, about 80 players here in Switzerland, and they have to think how they want to position themselves in the future.
Yeah, we are here to help them.
Very good. Yeah, no, well, actually, it's helping the doctors. The PIS providers, they are just providing the tool, but the doctors cannot do a lot if their provider isn't implementing it properly. Further questions? Then I would suggest.
I have one.
Yeah, go ahead.
How do you handle the fact that doctors, in writing documents, they do not have any grammar, they do not have any orthographics, they use the acronyms in very different ways. Even the single person can have a set of similar acronyms for the same thing. So that was the main problem for us. We saw that we're opening a box there that we never will be capable to manage.
Yeah, so that's a very good question. So how we approach this, the acronym issue, and it is an issue, I agree with you, is of course what you want to do in the end, or what is to extend it to what should be the actual acronym. But as you said, the different doctors use different acronyms. So what we do there is, at the moment, we attack it in a sense that we try to guess which is the most meaningful acronym in this way. And if we are not sure there, again, we have a decision point, we just leave it, because what is the power of LLM? What does enable us, or what was the key issue that was missing in the 2010 years when IBM Watson tried it, or anything, was that LLMs are capable of still getting mostly the syntactical semantic meaning of what was written, even though if there is like some compression issue by the doctor. So that's how we attack it. But we see that down the road in an uncertainty anyway, if we cannot fully extend this meaningfully, this acronym. That's how we attack that. So then this would just be yellow or red down the road.
And again, it comes down to manual corrections and overwritings.
Yeah, so I see it just to this human in the loop question. In my opinion, it is the wrong goal to get this human completely out of the loop, because you see it also in my domain. If you look at, for example, programming, there's always this hope of the non-technical people that at some point we can get rid of all these programmers and AI will replace them. But for me, it was just a game changer. I'm just 2 to 3 times faster in my daily life. But in the end, if it comes to really difficult decision, you still need someone that understands it. And I see this also in the medical space. There will always be this expert in the loop that needs to go over, at least for the next 5 or 10 years, in my opinion. Even though I'm riding this AI wave.
That's a very important message to the doctors. So a lot of doctors are afraid that they were going to be replaced by AI. And we had a very similar situation in the financial sector with these robo-advisors as they were announced. And that the startups came up with this idea immediately had thousands of enemies in the client advisors because they were all afraid to be replaced. But if they would have sold it as a robo-assistant, everybody would have taken it. And we should really consider it as an assistant and not as a replacement.
Yeah, attack the 80% of the really boring work, which the experts don't have to do because they're anyway just copy pasting and stuff, and the rest they can do. And then we can iterate from that, because I also believe that if we give them these tools, they will adapt, because they finally, for once in their life, see a benefit if they adapt to these tools. That is
there's another point which I would like to re-emphasize. You are taking existing documents, and as you quite rightly stated, if the information is not in the document, you cannot generate it. It's just not there. But if you provide the feedback while you're writing it, you could even provide a feedback about the completeness of the report in principle. You could tell the doctor, you're missing this and that. So it's very important to capture the information at the source and not to try later on to interpret it into the document. I see there's another question pending for a while. Stefan, go ahead.
Yeah, good morning. Just a quick question about the LLM. You mentioned that you use an open source version. I was wondering, like, can you say which one? And have you compared different open source LLMs and also to closed source LLMs?
Yeah, that's a very good question. So what we do is fundamentally, we want to be our pipeline. We want to build it very modular, as I said, for all these small steps. So we use different sizes of LLMs if we know, okay, this decision can be made by a smaller LLMs, for example, or for this decision, we need a larger LLM. And we also want to be model agnostic because, as you've seen this year, we also exchanged our LLMs like 3 times or 4 times. And we saw tremendous return in that. But what we see now is that the open source catched up to the let's say frontier models that are paid, and there's, in my opinion, in the next year we won't see this high amount of gain. But to answer your question about LLMs we do some tricks on the quantization that we can run it here in Switzerland because there's an actual GPU crunch in Switzerland. We use one of the 5 you will find if you search online. You can probably guess which one. And I will talk to, if it's not on YouTube, I will happily talk about that. But what I can say you, if I would say you now which one to use, it would probably not be true in 2 months. That is what I can tell you.
Okay, thank you. And you say it's really like comparable to the closed versions, because you could expect as the closed versions have still some room to improve, because they get access to much more data and so on.
Yeah, so what I see is fundamentally where we saw improvements in the closed source model in the last year, and we also see it in the benchmark, is they are really getting better in understanding your instruction. And that's why we feel they are better. But when it comes down to knowledge and actual quality of answers, they are not getting better anymore. That's also why, what are the innovations of ChatGPT, for example, this year? We have more efficient models, we have more different inputs, and we now include a search like Perplexity does. But they did not have a ChatGPT version 5 because they fundamentally also noticed that the more data they had, they need now like a magnitude of order of data to get to the next level. And in the 50 years that humans used to generate data, we generated that much data, like meaningful, actual good data, and it will take another amount of years until we have this actual good data again. So I see this more as a, hey, with this generation of models, we are kind of peaking in a sense, and it would need another, how do you say, architecture. So it was CNNs, now it's attention. We need another communication mechanism to get to the next step, to learn faster from less data like we humans do. We need 10 hours to drive a car. The AI needs, I don't know, and it still cannot drive a car. And for that, we are fundamentally limited by the physics on the hardware side, by the memory bandwidth, and this needs some material science question. But the technology is here to solve the problem. We just now have to apply it and attack the 80% that we can solve now, and then go step from there. That's how I see it, or we see it. The first key takeaway, in our opinion, is the technology is here, but we have to be very honest about where we stand and where we will stand in half a year, and communicate that to all the stakeholders in the system, which means healthcare professionals, politicians, and the people on the engineering side. I think this is the biggest takeaway we've seen so far. And the second one is, hey, let's start with simple use cases, implement them, because the status we have now is already so much better than what is going on right now in the whole medical space. So if we look at the data space that we have in Switzerland now, it's very disaggregated. There is a lot of data containers somewhere. And what we want, or what the vision is of us, and also I believe of DIDAS, is to get the patient back into control of the data. And if we want to have that in 5 or 10 years, it will probably take at least 5 years to get there. We need to make now the decisions and push the EPD forward, make it mandatory for everyone as we have, and then also implement the solutions on top to actually provide more values for the users now on the EPD.
If you are interested to join this group, send me a mail, then I can put you on the distribution list and you can listen in. So thank you very much to Jannis for the presentation. It was a very insightful, very interesting conversation and discussion. Thanks to all of you for your contributions. If you want to stay tuned, there's a YouTube channel, so you can subscribe, obviously. Be happy to see you again. With that, have a nice day and see you next time.